First of all, what problem is string theory trying to solve? String theory is trying to reconcile quantum mechanics and gravity. And let's take a step back and see what we mean by that. Because, in fact, we do understand gravity. Einstein's theory of general relativity describes gravity. And it's been tested. We've seen evidence of general relativity. Quantum mechanics we know very well. It's been tested on atomic scales. The point is that there exist scales that we can't test. They're much too small for experiments to be done in distance or much too high energy, where we wouldn't know how to make predictions. It would look inconsistent. In other words, in the regime of large things where cosmology or general relativity applies, we do fine. It's just quantum mechanics is negligible on those scales. At small scales, atomic scales, we can ignore gravity because gravity is so weak. But there exist tiny distances or very high energies where both forces would in principle be important. Those aren't ones that we can experimentally test, but even theoretically we believe we should have a theory which could work at all distance scales. Just the fact that we haven't been able to make experiments to test those yet doesn't mean there shouldn't be a theory that describes it. So people have been looking for a candidate theory of what's called quantum gravity for some time. So string theory is a theory of quantum gravity, or it's a candidate theory of quantum gravity. And it's based on the idea that fundamentally we don't have elementary particles, but we have fundamental oscillating strings. And particles are the oscillation modes of those strings. And if you can say, how could we not notice that it's strings and not particles? But if you think about it, if the strings are really tiny, they look like particles. We can't see it. To see that it's actually a string, you'd have to see the additional oscillations that a string can have. And to do that, you'd have to be able to test the energies that it would take to make a string oscillate. And it turns out we just haven't approached anywhere near those energies at this point.